Hello everyone and welcome to the lecture on Amazon Transcribe. So this lecture will contain all these topics. What is Amazon Transcribe? Features, supported languages, how Amazon Transcribe works, supported media types, Amazon Transcribe job queuing, transcribing streaming audio and partitioning speakers. So what is Amazon Transcribe? Amazon Transcribe is an automatic speech recognition service that uses machine learning models to convert audio to text. Amazon Transcribe can be used as a standalone transcription service or integrated into applications to add speech-to-text capabilities. The service offers advanced features including language customization for improved accuracy, content filtering for privacy and audience-appropriate language, multi-channel audio analysis, and individual speaker partitioning. Amazon Transcribe supports two transcription methods: real-time streaming for immediate transcription and batch processing for media files stored in Amazon S3 buckets. The service is HIPAA compliant, covered under AWS HIPAA eligibility model and BAA. It requires encryption of PHI at rest and in transit and offers automatic PHI identification at no additional charge across all regions where it operates. HIPAA stands for Health Insurance Portability and Accountability Act. It is a United States legislation that provides data privacy and security provisions for safeguarding medical information, and BAA stands for Business Associate Agreement. It is a contract between HIPAA covered entity and a business associate that will have access to protected health information. The agreement ensures that the business associate will appropriately safeguard the PHI in accordance with HIPAA regulations, and PHI is, as I talked about, is protected health information. So this is the feature for Amazon Transcribe. There are two more versions of it, which is Transcribe Medical, which is specific to medical, and Transcribe Call Analytics, which is used more in contact center or to provide analysis of your Amazon Transcribe text. So here we have all the features and whether it's eligible for batch or streaming. There are two modes, right? One is batch and one is streaming. So I'll just quickly run through it. So alternative transcriptions. So it's supported for both batch streaming and for Transcribe Medical also. And herein you can read for the last column, it's no, and post call is either it's post call or real time. So I'll just be focusing here. You can pause this screen if you want to look in detail. So these are all the features: channel identification, job queuing, language identification, multi-language identification, speaker diarization. So this I'll be covering what is this, and transcribing digits. So Transcribe works for both except for job queuing, which is only for batch because it's a queuing. So streaming, this is not applicable. Same for next feature categories: conversation analytics. So you have call characteristics, call summarization, custom categorization, real-time category events, real-time issue detection, real-time speaker sentiment and speaker sentiment. So here it's all no, but for call analytics, so basically you can provide some analysis on that. So this is post call. So there are two, we can say there are three modes: batch and streaming we have seen. Post call is after a call has been, after the transcription has been saved, then you can do a post call analysis. So moving on, next set of features is under language customization. So you have custom language models and custom vocabularies. So it's supported for both batch and streaming. And for medical, it's not, because it will only work with English language. And next is resource organization. So you have tagging, so you can tag your outputs, and then sensitive data. So you have identifying personal health information. For Amazon Transcribe, no. So this feature is not available. For medical, it's available for batch and streaming because of the nature of the industry. And identifying personally identifiable information, it's this feature is there for streaming data. So it can figure out in real time something like social security number, names, age, date of birth and stuff like that, addresses. And redacting audio, so this is no, but this is available for call. And moving on, you have vocabulary filtering, so this is available for both. And redacting transcripts, this is also batch streaming, both it's available. And subtitles, it's only available for batch. It cannot do for real time because it's very time consuming or resource intensive. Okay, these are the supported languages, and there are over 100 plus language. So most of the popular languages are there. So I have put, so this may not be the most up to date, but you will see most of the popular languages are there. So you will check the official documentation, like whether they have added new languages. but if it's there on this screen, that means it's already supported. Then how Amazon Transcribe works. So Amazon Transcribe uses machine learning models, as I talked about, speech to text. Then you have transcript content. So in addition to the transcribed text, transcripts contain data about the transcribed content, including the confidence scores and timestamps for each word or punctuation mark. So this will be like additional metadata, like what is the confidence score in terms of this being able to tell whether this what was spoken was correctly figured out as this particular word. So there will be confidence score because it uses machine learning rather than pre-fed like data. So transcription methods. So this one I already talked about. There are two main categories. One is batch transcriptions. So transcribe media files that have been uploaded into Amazon S3 bucket. So for this you have to first put in S3 bucket and then you can do a batch transcription. For streaming transcription, transcribe media streams in. This one is real time. And these are the supported media types. So you have under batch these formats: AMR, FLAC, M4A, MP3, MP4, OGG, WebM, and WAV WAV. For streaming, there are three formats: FLAC, OGG Opus, and PCM encoding. But the recommended formats is FLAC and WAV, WAV with PCM 16-bit encoding. And for streaming, again it's same: FLAC and PCM signed 16-bit Little Indian audio. And this does not include WAV WAV. So this is PCM is slightly different format, but that is applicable only for streaming. So this one next feature is Amazon Transcribe job queuing. So job queuing allows you to submit more transcription job requests that can be concurrently processed. Without job queuing, you must wait until one or more requests are completed before submitting a new request once you reach the quota of allowed concurrent requests. So basically there is a limit on how many it can currently process, and once that is that you have reached, so let's say that limit is 10. So after 10 it will be queued. All your this is only for batch, right? So you have, let's say you have uploaded a lot of files and you have given a task within the transcribe to convert all this. So it is because usually there will be a lot of files when you it's not like 10, you can have upload multiple files, so it gets queued. And job queuing is optional for transcription job request, and it is automatically enabled for post call analytics request. So it's batch and post call. So once you have any batch job, post call analytics will if you want this will also get queued. So how job queuing works? So when enabled, so you have to enable it first. Amazon Transcribe creates a queue for request exceeding your limit. So if there is a certain limit, it will once you cross that, it will get automatically queued. So as soon as a request is completed, a new request is pulled from your queue and processed. Queued requests are processed in FIFO order, first in first out order. Queue limits and performance. So you can add up to 10,000 jobs to your queue, and exceeding this limit results in limit exceeded concurrent job exception error. And for optimal performance, Amazon Transcribe uses up to 90% of your quota, which is a bandwidth ratio of 0.9, to process queued jobs. And these are the default values that can be increased upon a service request. Concurrent processing. So if you enable job queuing but do not exceed the quota for concurrent request, all requests are processed concurrently. And job queuing provides flexibility in managing large volumes of transcription requests while maintaining system performance. Next is we'll see how to transcribe streaming audio. So this is the different feature, streaming. So queuing is more batch, and now we are looking at real-time transcription. So Amazon Transcribe streaming enables real-time transcriptions for media content, delivering streaming media and returning transcripts instantaneously, unlike batch transcriptions which require file uploads. Streaming media types supported by Amazon Transcribe include pre-recorded content like movies, music, and podcast, as well as real-time media as live news broadcast. So in case of a batch, you have input S3 and output could also be something where you download an S3 or directly download from the transcribe console, but real time you can just stream audio and get the transcription in real time. You can see on screen, or you can output through SDK or API, but you can have that, as well as you can upload your movies, music, or podcast audio file directly, and you have to wait in the sense it will be like real time. So as soon as you upload, it will start transcribing, and you will see the text right in front of you. So both the cases are possible. Common use cases for Amazon Transcribe streaming include a live closed captioning for sporting events and real-time monitoring of call center audio. And this can include podcast also if you have any kind of live events. So this will be very beneficial. Streaming content is delivered to Amazon Transcribe as a series of sequential data packets or chunks which are transcribed instantaneously. Advantages of streaming over batch transcription include real-time speech-to-text capabilities in applications and faster transcription times, although this increased speed may sometimes result in accuracy limitations because it has to do very fast. So there can be some loss of accuracy when compared to batch transcription. Amazon Transcribe offers multiple options for streaming, including SDKs, which is the preferred and which most likely you will be using in your real-time applications, because you will not be opening Transcribe console. That is only for manual testing and making sure the service is as per your expectation. But you will most likely using some kind of SDK like Python SDK, Go SDK, or Java SDK, and you will be integrating with your applications. Next is you can use HTTP to WebSockets and can directly use in the management console also for basic manual checking of features and testing. The next feature is partitioning speakers, and this is called as diarization. So speaker differentiation. So with speaker diarization, Amazon Transcribe can distinguish between different speakers in your transcription output. And it can differentiate up to 30 unique speakers. Labels from each speaker will have a unique value, something like speaker 0 to speaker 9. So it can go all the way to up to speaker 29. So because up to 30 unique speakers it can identify in the audio. So transcript output structure. So request with speaker partitioning. So we have to ask for speaker partitioning enabled. Include. So once you have included this feature, you have standard transcript sections, which is transcripts and items, and then you have additional speaker labels. So the whole transcript and items, then you will have all the speaker labels. So I'll be covering that in one of the code in next few slides. So speaker label section. So speaker label section is grouped by speaker and contains the channel label, like from which audio it has coming, the number of speakers and segments for each utterance. So this is at a higher level. Now at the segment information, so each segment includes the start time, speaker label, end time, and items with detailed timestamps. So on the left is like how many speaker labels are there, like and what was the channel was the used, number of speakers and segments. So inside this segment, this information will be there. So let's say there are two speakers, there will be two segments, and let's say speaker A speaks, and then speaker A label, and what time to what time speaker A has spoken. Then there will be items like word occurrences and all, and those will have some more timestamps with metadata. So this is the sample output of a transcript request. So I'll be explaining this. So here you will have channel label. So channel label indicates the audio channel that is being transcribed, and this is useful for multi-channel audio. Then it will tell you speakers, that how many speakers. It shows the total number of unique speakers that it has identified in the audio, followed by speaker segments. So you have speaker first. Start time represent the beginning of a speech segment in seconds, and it will provide a label. Speaker label uniquely identifies each speaker. Speaker 0 to 1 to up to 29, then followed by end time. So end time marks the conclusion of speech segment in seconds, and then the first segment has finished. Then let's say second speaker has started speaking, and it will tell different speaker. Speaker 1 indicates a change in speaker, and the second speaker's start time, end time, and other items. That's all. Thanks for watching.